Okay, so the next vector question is from the C34 paper in Jan 2018. So here, question number 7. With respect to a fixed origin O, the lines L1 and L2 are given by the equations. So line 1 is given by this 13i plus 15j minus 8k plus lambda 3i 3j minus 4k. So you do realize here, this is the question vector plus the vector with lambda is the direction vector. So they have given you two lines similarly. Show that line 1 and line 2 meet and find the question vector of their point of intersection. So 6 marks. Okay. So now we just the method here is quite simple, right? So what we'll do here is first let me write this in the vector form. So where I write it as a column vector. So R is 13i. So it's 13, 15 minus 8 plus lambda times 3, 3 minus 4. So when you add everything together, it's 13 plus 3 lambda, 15 plus 3 lambda, minus 8 minus 4 lambda. Is that okay? So this is the these are the coordinates that lie on line 1. And then line 2, you get R equals 7 minus 6, 14 plus mu times 2 minus 3, 2. So when you add everything, it's 7 plus 2 mu minus 6 minus 3 mu 14 plus 2 mu. Do you agree with me? This is line 2. Then we are supposed to show that the line 1 and line 2 meet. So basically what you do here is you have the x, y, z general coordinates of the line 1 and line 2. I added the two parts here together. So let's equate, get 3 equations. So first equating the x coordinate, I get 13 plus 3 lambda equals 7 plus 2 mu. So this gives me the equation 3 lambda minus 2 mu equals 7 minus 13, isn't it? 7 minus 13 is minus 6. Do you agree with me? The second equation I get by equating the y coefficients. That gives me 15 plus 3 lambda equals minus 6 minus 3 mu. So I get here 3 lambda plus 3 mu equals minus 6 minus 15 is how much? Minus 6 minus 15 is minus 21. So I think you can see I can divide the whole equation by 3, isn't it? So we'll divide the whole equation by 3. That gives me lambda plus mu equals minus 21 divided by 3 is minus 7. Okay. And then let's solve these two equations. So I'll make maybe lambda the subject. So I'll get lambda equals minus 7 minus mu here. Let's substitute that value into the first equation that we got. So 3 times lambda is minus 7 minus mu. 3 lambda minus 2 mu equals minus 6. So this is going to be 3 times minus 7 is minus 21. 3 into minus mu is minus 3 mu. Minus 2 mu equals minus 6. Is this okay? I get here minus 5 mu equals minus 6 plus 21. So how much is minus 6 plus 21? That's 15, right? Minus 5 mu equals 15, which means mu equals 15 divided by minus 5. 15 divided by minus 5 is minus 3. Is this okay? So then lambda will be substitute the mu equal minus 3 into one of these two equations. So I'll substitute to the one where lambda is already subjected. Minus 7 minus mu is minus 3. So that gives me lambda equals minus 7 plus 3, which is minus 4. Do you agree? Minus 7 plus 3 is minus 4. Okay, so I have the lambda value and I have the mu value. Now, what do we do? How do we show that the lines intersect? So you equated the first two equations. I used the first line and I used the second line, and then to show that they intersect, we go for the third line. So we take the z coordinate, the third coordinate, equate them, and then substitute the lambda and mu values we found from the first two equations. And then if the, so let's get it. So what do we have here? Minus 8 minus 4 lambda. This is the checking part where we check whether the lines actually meet. So we use the lambda and mu that we first, wait, minus 8 minus 4 lambda. So it's equal to 14 plus 2 mu. So I'm saying I'm equating it to I'm equating it to 14 plus 2 mu. And then what do we do? In the checking part, now we already got the lambda and mu answer in the previous from the previous two equation. So you substitute the mu and lambda value and check whether the third equation will equate to each other or not. If they equate to each other, that means the lines will intersect. If they do not equate to each other, the lines will not intersect. Okay, so what do we get here? Minus 8 minus 4 into lambda is minus 4. The other side I get 14 plus 2 times mu is minus 3, isn't it? Simplify. Minus 8, the multiplication gets the priority. Minus 4 into minus 4 is plus 16. Minus 8 plus 16 is 8. Do you agree with me? Here I get 14 plus 2 times minus 3 is minus 6. 14 minus 6 is 8. So I think we can see it's equal to each other. So third coordinate equals to each other, which means what? Line 1 and line 2. Line 1 and line 2 intersect. Do you agree with me? So in this case, we realize that line 1 and line 2 intersect, and therefore we need to get the point of intersection. They ask us to get the point of intersection. How do you get the point of intersection? The point of intersection, what you could do is you can use your lambda value or the mu value and substitute that into either the line 1 equation or line 2 equation. So if you're going with line 1, you have to substitute the lambda value. If you're going with line 2, substitute the mu value and then get the point of intersection. Okay. So if I go with this one, so let me, maybe I'll go with the second one, 7 plus 2 mu. 7 plus 2 mu. The other point is minus 6 minus 3 mu. The other point is 14 plus 2 mu. Substitute the mu value. You can go with any one of the two equations. 7 plus 2 mu minus 6 minus 3 mu. 14 plus 2 mu. Okay. Substitute the mu value. Seven plus 2 times mu value was minus 4, right? Sorry, mu value is minus 3. So mu value is minus 3, minus 6 minus 3 into minus 3. 14 plus 2 into minus 3. Substitute, I get here, how much do I get here? 7 plus 2 into minus 3 is minus 6. This one minus 6 into minus 3 into minus 3 is plus 9. This is 14 plus 2 into minus 3 is minus 6. How much is the final answer? The point of intersection. 7 minus 6 is 1. Minus 6 plus 9 is 3. 14 minus 6 is 8. So I get the point of intersection as 1, 3, 8. Is this okay? Did you get the same answer? Then in part B, find the acute angle between line 1 and line 2. Okay, so you know that the lines intersect. So you need to find the acute angle between the lines, between the intersecting of the two lines. So how do you get the acute angle? The acute angle of the point of intersection, you do realize when you have two lines, what do we take for the two vectors? For the equation, you know, we normally use cos theta equals A dot B over modulus A modulus B, isn't it? This is the equation we use. What do we use for A and what do we use for B? So here the angle theta is the angle in between A and B. So here line 1 and line 2, what do we use in line 1 and line 2 to get the angle? We use the direction vector of line 1 and direction vector of line 2. Okay, so make sure you use the direction vector of line 1 for A and direction vector of line 2 for B. Okay, so then let's get here. A is going to be direction vector of line 1. A is going to be 3, 3 minus 4. And B is going to be 2 minus 3, 2. So A dot B will be 3, 3 minus 4. Dot product B is 2 minus 3, 2. So I get here 3 times 2, 6. 3 into 3 minus 9. Minus 4 into 2 minus 8. How much is the answer? A dot B answer is? Yeah?
minus 11.
Minus 11. And then let's get the modulus A. Modulus A is 3 square plus 3 square plus minus 4 square square root. How much is this?
Root 34.
Root 34. Modulus B will be 2 square plus minus 3 square plus 2 square square root.
Root 17.
Root 17. And then I will be, so now we are ready to go with the equation. Cos theta equals A dot B is minus 11 divided by root 34 into root 17. So do you remember what I was telling you in the previous sections, in the previous questions when we were doing vectors? You remember, if you're taking cos inverse of a negative part here, you will surely get an obtuse answer. Okay, so they ask you here, I think they very clearly, they ask you to get the acute answer, isn't it? Do they say, yeah, find the acute angle. So to get the acute angle, one thing that you could do is you could take the cos inverse of the positive part, or else you could take the cos inverse of this entire thing and subtract the answer from 180. So I think I was demonstrating this in the previous question. The cos inverse, if you type minus 11 over root 34 times root 17, I get the answer as 117.228. So then what we do is we subtract the answer from 180 and we get the relevant acute angle. Okay, so 180 minus answer and you get the acute angle as 62.7715. So they want the answer to 1 dp. Do they say whether it's in degrees or radians? In the question, they do not tell you whether they want in radians or degrees. So you could keep in either. So in this case, because they have not, in the question, they have not mentioned anywhere specifically whether it's radians or degrees. So I'll go with degrees. Okay. So I get here, cos inverse answer was 111.5245. So acute angle 180 minus 111.5245. So 180 minus answer 68.475. When you make it to, they ask you to give the answer to, yeah, they don't mention the degree of accuracy here. So you can keep it to 3 significant figures in that case. So 68.5. So 68.5 to 3 significant figures. Is that okay? Okay, so then, yeah, so then the next one, point A has position vector minus 5i minus 3j plus 16k. Show that A lies on line 1. So how do you show that A lies on line 1? So basically, this is the line 1 equation. You have to show that there is a lambda value. Now, you know, when you input a value for lambda and when you add it up, you can get the, you get coordinates. You get coordinates that lie on line 1. So basically, if you could find the lambda value, that can give you the answer minus 5 minus 3, 16. Then I mean, if you can find the lambda value who makes this equation, when you substitute the lambda value, if you could get minus 5 minus 3, 16, then in that case you can show that that this particular point lies on L1 because there's a single lambda value that satisfies this equation to give you this answer. Okay. So then how do we find this? So for the first one, now you can see I have the general x coordinate here, 13 plus 3 lambda. Can you see? So the 13 plus 3 lambda is the general, it's the general x coordinate, coordinate of the x coordinate. The general x coordinate that lies on line 1. So any coordinate, any point on line 1, the x coordinate has to follow the format 13 plus 3 lambda. Any coordinate in the line 1, the y coordinate should follow 15 plus 3 lambda. The z coordinate of any point on line L1 follows minus 8 minus 4 lambda. So what you have to do is you have to show that there is a single lambda value that can generate this particular answer. A single lambda value who is capable of giving you this answer. So what I'll do here is to get that lambda value, we will just try with the x coordinate 13 plus 4 lambda, right? That's the x coordinate 13 plus 3 lambda. I'm sorry. 13 plus 3 lambda, I'm going to make it equal to minus 5 because minus 5 is a specific x coordinate here. So I'm going to find the lambda value who is capable of giving me minus 5. So 3 lambda equals minus 5 minus 13. 3 lambda equals minus 5 minus 13 is minus, how much? Minus 18, isn't it? So lambda equals minus 18 divided by 3 is minus 6. Okay, so lambda is minus 6. And then, so this is the lambda value. What you could do now is you could substitute lambda as minus 6 into this equation and then show that the xyz coordinates become minus 5 minus 3, 16. Okay, so you can kind of like do this as a rough work and see what's the lambda value that satisfies. And then use the lambda value minus 6 into this equation and show that you get this answer. Or else another approach is where you keep doing in this method. That means where you take the y coordinate. You take the y coordinate 15 plus 3 lambda and make it equal to minus 3. And then from that also you get lambda is minus 6. And then you also show minus 8 minus 4 lambda, the z coordinate equals 16 and show that the lambda value is again 6. So you have minus 6. So which means there's a uniform lambda value that is giving you these 3 answers anyway. So anyway, I prefer to use the first method. I will say when lambda equals minus 6, the line 1 r equals 13, 15 minus 8 and minus 6 times 3, 3 minus 4. This is the equation, right? 13, 15 minus 8 plus lambda is minus 6 times 3, 3 minus 4. How much is the answer? So this is 13 minus 6 into 3. This is 15 minus 6 into 3. And this is minus 8 minus 6 into minus 4. So when you simplify this, we should get, what do we get? We get minus 5, minus 3 and 16. Am I correct? We should get this. Therefore, do you agree with me? You can type in the cal. You should definitely get this because it's just 1 mark. You don't need to waste a whole lot of time. All you have to do is you could like mentally get this lambda value from your head and just you don't even need to show this step. You could just say lambda equals 6 and get the answer and that's it. Therefore, A lies on L1. Okay, so this is all you need to do. So part D, the point C lies on L1 where AB vector is equal to BC. Can you see? They are saying here the point C lies on line 1 where AB is equal to BC. Find the position vector of C. Okay, so what should we do first? First, let's draw a quick sketch of what's happening here. Okay, so let's draw a quick sketch. Part D. I'll do it over here. So to obviously to do part D, you need to kind of have a visual idea of what's going in part A, B, C, and then you go to part D. So I'm reading again. We know that line L1, L2 are what? We know that line 1 and line 2 actually intersect. They intersect and they intersect at the point B. Okay, so let's draw line 1. That's line 2. The intersecting point is point B. And find the acute angle between line 1, line 2. That too we have found. The acute angle also we have found. And then point A has position vector minus 5, minus 3, 60. Show that A lies on line 1. Okay, so this means point A is on line 1. Shall we write the coordinate also? Minus 5, minus 3, 16. So this point lies on line 1. You can see I have marked it here. Point B coordinate also we found, right? Point of intersection. What was the point of intersection that we found? Point of intersection was 138, isn't it? Point of intersection is 138. Okay, and then what else do we have here? The point C lies on L1, line 1 again. The point C lies on line 1. Where A, B vector is equal to BC vector.
Minus 1.
Sorry, what did I do wrong?
-1 for the B.
Minus 138. Okay. Okay. Yeah. No, it's not -1. It is +1. 7 minus 6 is +1, isn't it? It's +138. Okay, so when they say point C lies on line 1 where AB equal BC, you need to realize here that they are equating not just, I mean, you can see AB on top of AB, the arrow is there, which means they are equating here AB, BC are not just simple quantities, they are vector quantities. You are equating two vector quantities. So when you are saying two vectors are equal, you are not just equating them in the sense of their magnitude. Okay, equating vectors, a vector has two aspects, the magnitude and the direction. So when you say vector AB is equal to vector BC, it means you are equating it with respect to the magnitude and also with the direction. So which means the directions also must be parallel. Okay, so they say here point C lies on line 1 where AB, so I think you can see according to the way I have marked, AB is in this direction. So vector AB, they tell you here vector AB is equal to vector BC. And they tell you the point C is on line 1. It's on line 1. So vector AB is equal to vector BC. You need to realize it's on line 1. And since the directions, you know, it's on the same line 1 and the directions are the same. So AB is, according to what I have drawn here, AB is to this direction. So BC is over here. Okay, so AB is equal to BC. Are you with me? So now what you need to do is to get the position vector of C. So, you know, AB is B minus A. BC is C minus A. Okay, so here simple A, simple B, simple C are the position vectors. And right now what I need to do is I need to find the position vector of C. This is the question mark. This is what we need to find. So how do I get the position vector of C? B minus A. So B is 138. Minus A vector is -5 minus 3, 16 equals C. C vector is what I'm trying to find. C minus A is -5 minus 3, 16. Do you agree with me? So let's simplify everything together. Make C the subject. So C will be equal to 138 subtracting with C minus B. I'm sorry, this is not C minus A, this is C minus B. Yeah, sorry, I made an error here, right? BC is C minus B, not C minus A. Okay, AB is B minus A, BC is C minus B. So I have to change here, right? So -5 minus 3, B vector is 138. So I'll change that. This should be 138. I hope you guys are okay with that, right? C minus B, B is 138. So this is 138 minus -5 minus 3, 16. The minus part comes as plus and you get the vector here 138. Okay, so I brought this over here. This negative becomes positive. So now add everything together and you get the position vector of C. So what's the position vector of C? Add everything. 1 minus -5 plus 1. How much is it? 1 minus minus is 1 plus 5. That is 6. 6 plus 1, I get here 7. And here 3 minus 3, that's 3 plus 3, 6. 6 plus 3 is 9. 8 minus 16 plus 8. 8 minus 16 plus 8 is 16 minus 16, that's 0. So position vector, they ask you to get the position vector of C. So OC is 790. Or you could say OC is 79 plus 9J. Okay, so you could say OC is 7i plus 9j plus 0. Okay, so leaving it like this is perfectly okay. Okay, so this is the answer for part D, the position vector of C.